All right, so let's do this calculus problem. And the instructions would be find the equation of the tangent line for the function given at x equals 1. Now, just some review here. This is a polynomial, so you know it's continuous everywhere. It is not even or odd. If you substitute in negative x, you're not going to get negative f of x or f of x, so this is neither, okay? This is not even or odd. The domain is all reals, and I really don't need any of that for this, okay? But first thing, if I'm going to do an equation of a tangent line, I need point and slope for a line. So first thing I do is I find the point by substituting in and finding that when I substitute 1 in the function, I get 5. And now I have to find the slope, okay? The instantaneous rate of change, boom. I have to find the instantaneous rate of change. I have to bring point Q back to point P. That's what I talk about in my class all the time. I have to change this average rate of change, this dotted line right here from Q to P. I have to bring point Q back to point P, making this distance here, h to 0. So I do that by using this and changing the secant line. So we know it's a function because it's a parabola opening up. But when I put in this, I know, because of all the practice we've done, that the h in the bottom has to cancel. And if it doesn't cancel, you have a math mistake. So you do the math. And this is just algebra now, and there's a lot of it. And like a lot of calc teachers, I go very fast through it. So again, I have to actually take a plus h times a plus h. Hopefully you get that memorized. And I distribute the 3, and I'm really careful here to not make a math mistake. 3h squared minus 2a minus 3h squared, all over h. All right, right, there's a limit. I try to plug in 0 at this stage right here in the bottom 0, so I can't do that. We knew that. The next thing would be to factor or expand. This is an expansion one, right? So we expand it completely. And then I find that 2a and negative 2a, 3a squared and negative 3a squared cancel. And the other 3 terms, every other term that's available has an h. So we know we've done it correctly. I will actually show the factoring here. You pull out the h. Very careful to get all the terms. And if you are doing an average rate of change, you have just developed an equation starting at a for duration h. This will give you the average rate of change between any 2 points on this function. But that's not what you did this time. This time I want the instantaneous rate of change. I want the derivative. So I take h to 0, which means that term goes to 0. And I get that the derivative, f prime of a, is 2 plus 6a. Awesome. Because now I can plug in my a value. And I was trying to find the equation of tangent line at x equals 1. And I get a slope of 8. I now have a slope of 8 and 0.15. We're going to use point slope form every time in calculus, point slope form. So I get y minus 5 equals 8 times x minus 1. Equation of a tangent line at x equals 1 for the function 2x plus 3x squared.